Now, we were talking about two charged spheres, and then those spheres attract each other. So now we're looking at the field. So a positive charge has a certain field, and a negative charge has a certain field. So can you draw the two fields? Can you draw the two fields that a positive pushes out and a negative pulls in? So something like this. Can you draw those fields if asked to draw them? So moving outwards. So just be careful of that. Make a note in electric circuits, drawing electric fields. They love bringing that up because that determines whether you understand the difference between question 6 and 7. Question 6 is talking about two charged points repelling two charged or rather objects. They either repel or they attract. Then question 7, that's using Coulomb's law. Question 7 is looking at what happens if I have a charged object, I have another charged object, and then I have a particle. So then this will push it that way, and then this will push it that way. And then I'll calculate the something we call the net electric field strength in newtons per coulomb. Does that ring a bell?
Yes, sir.
So you have to really distinguish because I haven't studied this in a long time, but I definitely remember I had to differentiate between I have a particle. Let me just go down to the formulas. Really have to do at least one circuit. So newtons per coulomb, it's this here. It's F divided by Q, newtons per coulomb. Then that's for the force. Then this is for the electric field. So that's why you won't have a Q1 and a Q2. You only focus um on one single particle. Do you guys do electrodynamics? 'Cause I don't think you guys do that in term two. Electrodynamics.
No, 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 sir, no, sir.
Because I think that's more term three. During when I was getting taught physics, I had a really interesting teacher. So you have to differentiate between why am I using 1Q? It's because I'm measuring what happens with the field. And that's why I asked you, can you draw your this diagram that shows outward pointing arrows for positive field? Because that's what they normally ask you to draw, because that actually pushes out, because you're talking about magnetism in this case, positive and negative, and this is where you're building up to magnetism and electrodynamics. So I'll send you the diagrams with those sketches. So differentiate
Yes,
between a particle or point P, that's measuring electric field strength. And then so I'm looking at the net force, that's Coulomb's law. So you have to study that definition, but it's the strength of the field as it acts on a point. So it's force per Coulomb, because it's pushing it away. But just study your list of definitions. I think you guys do get given. Also send me your scope, because I did tell you to send it last time, but I think you just in exam mode. Um, so here they
yes,
tell us the net electric field strength at point P is 800 to the right. That's important. So here's P. P will be pushed by Q1. So we don't label it as F anymore. We label it as electric field strength. So E by Q1 will be pushed in that direction by E of Q1. And then, so I'll let you do the next one. And then we don't know what that charge is, but we do know it's moving to the right. Then we have some charge Q2. We don't know whether it's positive or negative. We have to be careful. We only know that this is positive, and we have the length. That'll be 6. That'll be 6. And we have the net electric field strength after we add the two. So Q2 could either be acting in that direction or it could be acting in that direction. We're not really sure. That's what makes these questions a bit harder because they're not really asking for straightforward net net electric field strength. So we'll say 8,500. 8,500. That's equals um the first one. If we write it, it'll be K, then Q. So nano. So micro is 9. Nano is, we really have to study these different units because I'm also getting um
Uh,
so micro,
I think
this is 10 to the
with
power of
the
negative
times 10,
6. Then the micro one is -9. We really have to study those. Then from centimeters to meters, what happens? We divide by 100. So multiply by 10 to the power of -2. That's equivalent divided by 100. Then I'll square that. I'll add that plus K. Um, so I'm not sure about the sign. I just know that it's to the right. It's positive. So I'll say plus K. And then we don't know what Q is. Then R is going to be 8. We'll definitely check the memo here. R is going to be 8. Then we can solve. I'll square that to convert. Then we can solve for Q. And depending on how big this number is, that'll tell us whether Q is negative or positive, and that'll also inform the direction. Because in this formula, you never really enter negative or positive. That's determined by the direction of your arrows. So you never really enter positive or negative. Let's just quickly check the memo. Just trying to cover at least 3 question papers in the because I feel like that's practice. Just to get your mind ready. So we'll start with question 6. Question 6, we had to draw our free body diagram. So we did draw that free body diagram. And then we had to state we had to state Coulomb's law in words, 2-point charges per product with the charges. So we stated that correctly. And then had to calculate R. So do you see why? Oh, it's actually X over Y. That's an interesting way of doing it. Looking at the angles themselves. Um,
wait, so can you just
I
go
would
back
have never.
to the free, can you just go up to the free body diagram quickly? I just want to see what it. Okay,
uh,
okay, okay. Thank you.
Okay, this is interesting because here they're using the forces themselves. to find the angle. And I think here they are using the fact that, so remember in grade 11 you first do vectors. So you first talk about vectors. Do you remember the topic of vectors?
Yes, sir.
So they're using the fact that if you have two vectors, then the angle here allows you to find um and I did try using gravity, but then I had another unknown. But and then T was also an unknown, so you should use FG and F FE, which is on your triangle. And here they are using a grade 11 methods which test your ability to um use trig in terms of vectors. It's all about trig, it's all about vectors. Then question seven, so I'm not sure why they made that one negative, because I was really trying to move away